Hello, good morning, students. Now we'll go to unit number 5, solid geometry. In this solid geometry, first we'll see the system which contains the Cartesian, spherical, polar, and cylindrical coordinate systems. Then after that, we'll go to the three main parts: sphere, cone, and cylinder. Any point in the space can be described by the Cartesian coordinates system x, y, z. The spherical polar coordinate system r, theta, phi, and the cylindrical coordinate system rho, pi, and z. That means any point in the space can be described by these three coordinate systems. The first is a Cartesian coordinate system, the second is a spherical polar coordinate system, and the third is a cylindrical coordinate system. Then we'll see these systems step by step and the relation between these. The first is the Cartesian coordinate system. So in three-dimensional geometry, we draw three mutually perpendicular lines. That is x dash o x, y dash o y, and z dash o z. These are three mutually perpendicular lines, and then intersecting these three at a point O. This is the origin, which is having 0, 0, 0. Then this is a figure where you are having a point in the space. That is a point P, X, Y, Z. Then these lines, which you are having three mutually perpendicular lines, are known as the coordinate axis, and OX, OY, OZ. That is OX, OY, and OZ denote the positive direction of X, Y, Z axis respectively, while OX dash, OY dash, and OZ dash denote the negative directions of X, Y, Z axis respectively. The plane in which x-axis, y-axis lies is called the xy plane. The plane in which y-axis, z-axis lies is called the yz plane. The plane in which z-axis, x-axis lies is called zx plane. Then the equation of a xy plane or xoy plane is z is equal to 0. Now here this is xy, z is absent, and put that z is equal to 0 to find the equation of the xy plane. So equation of an xy plane is z is equal to 0. Similarly, the equation of a yz plane is x is equal to 0. So here x is absent. The equation of z axis, that is the equation of a zx plane, that is zox plane, is y is equal to 0. The above three planes are known as coordinate planes. That is xy, yz, and zx planes are known as the coordinate planes. And these planes divide the entire space into 8 equal parts known as octants. The octant in which x, y, z are positive is known as a positive octant, similar to two dimensions. The position of a point P in the three dimensions is denoted by three real numbers x, comma, y, comma, z. These are the distances respectively from the origin to the intersection of perpendicular dropped from the point P to XYZ planes. That is, if you see this figure, you are having this is a point P, then Z is a perpendicular dropped to the z-axis, and then the corresponding values of x and y, they will be denoted by a point in the space p of x, y, z. So therefore, this becomes a Cartesian coordinate system where p is denoted by the three real numbers x, y, z. So in the xy plane, you are having m of xy is equal to 0. In the xyz plane, that is p of xyz, then we'll see the corresponding values in the form of the spherical polar coordinate system. In the spherical polar coordinate system, this point P is having the coordinates r, theta, pi, where r is, this is the origin, r is the distance of the point from the origin, theta is the angle made by this OP through positive z-axis, and pi is the azimuthal angle, this is the angle made by the plane. Then in the above figure, OP is equal to R. Let theta be the angle made by OP with the positive z-axis. Let pi be the angle made by OQ with the positive x-axis. In this system, R lies between 0 less than R less than infinity. Then theta lies between 0 less than or equal to theta less than or equal to pi, and pi lies between 0 less than or equal to pi less than or equal to 2 pi. The numbers denoted by r, theta, pi, which can be associated with the point P, are called as spherical polar coordinates of the point P. Then the relation between the Cartesian and the spherical polar coordinate system. We have seen the two systems where the point P of xyz is denoted in the Cartesian coordinates, and that P is also denoted by the polar coordinates r, theta, pi. Then we want to find what the relation between these Cartesian coordinates and the polar coordinates are spherical polar coordinates. Then what we do? Let this xyz be the Cartesian coordinates of the point P. So this is a point P whose Cartesian coordinates are xyz. Then from the adjoining figure, from this figure, OP is equal to the distance of the point P from the origin, and then OP is equal to distance of the point P from the origin 0, 0, 0 and x, y, z. Therefore, R is equal to square root of x square plus y square plus z square. So that is the distance formula. That is the distance between the point x, y, z and the origin 0, 0, 0 is equal to R. R is equal to root of x square plus y square plus z square. Then from a triangle OPQ, again in this triangle OPQ, you are having this is O, then this is P and this is Q. OPQ, OP is equal to R and PQ is equal to, that is PQ is equal to R sine of pi by 2 minus theta. That is PQ is equal to Z. This is PQ, this is Z. Z is equal to, this is R, sine of pi by 2 minus theta is cos theta. So therefore, Z is equal to R cos theta. Then OQ is equal to R cos of pi by 2 minus theta. So again, if you see, this is OQ. OQ is equal to R cos of pi by 2 minus theta. Then OQ is equal to R sin theta. Then from a triangle ONQ, ONQ, ON, this value ON is equal to OQ cos pi. This is ON is equal to OQ and this is equal to cos of pi. Therefore, ON is equal to X. This is X axis. Therefore, ON is equal to X is equal to OQ is already known to you. That is equal to R sin theta and this is cos pi. So, therefore, X is equal to R sin theta cos pi. This is a Cartesian coordinate and this is a spherical polar coordinates. There is a relation between the Cartesian coordinate and the spherical polar coordinate is given by x is equal to r sin theta cos pi. Now, ON is equal to OQ sin pi. So again, you are having this QN, this is QN is equal to OQ sin pi. Therefore, Qn is equal to y and OQ is already known to you, that is r sin theta and this is sin pi. Therefore, y is equal to r sin theta sin pi. Thus, these three equations, x is equal to r sin theta cos pi, y is equal to r sin theta sin pi and z is equal to r cos theta are the relations between the Cartesian coordinates x, y, z and the spherical polar coordinates r, theta, pi. Also, from 1 to 3, x, y, z are positive. Therefore, r is equal to square root of x square plus y square plus z square. So, by making use of the above three relations, we can show that r is equal to square root of x square plus y square plus z square, the relation between r and x, y, z. Then theta is equal to tan inverse of square root of x square plus y square divided by z. This is the modulus. Modulus thing, if this is a negative value, then you'll have to take a positive value of that. Then if this is a positive value, then that remains as a positive value. And then pi is equal to tan inverse of y upon x. Then also we see that r lies between 0 to infinity, theta lies between 0 and pi lies between 0 to 2 pi. Then we'll see the next coordinate system, that is the cylindrical coordinate system. Refer the figure. Let OQ is equal to rho, PQ is equal to Z. Then from the triangle OQN, ON is equal to OQ cos pi. That is NQ is equal to OQ sin pi. That for x is equal to rho cos pi, y is equal to rho sin pi and z is equal to z, where rho is equal to square root of x square plus y square and pi is equal to tan inverse of modulus of y upon x. Hence, P of rho pi z are cylindrical coordinates of the point. So therefore, we have seen all the three coordinate systems: Cartesian coordinate system, spherical polar coordinate system, and the cylindrical coordinate system. Cylindrical coordinate system is put in the form of rho pi z. The spherical polar coordinate is put in the form of r theta pi, and the Cartesian is in the form of x, y, z. So these are the three coordinate systems. Then we'll see some of the examples where we want to convert the spherical polar coordinates, cylindrical coordinates for the corresponding Cartesian coordinates. For example, find the spherical polar and cylindrical coordinates of the point P of xyz is equal to P of 1, 1, 1. So, P of 1, 1, 1 represents a point in the space where x is 1, y is 1, and z is 1. So, you want to find what are the corresponding points in the form of r theta pi, that is the spherical polar coordinates, and rho pi z, that is the cylindrical coordinates. So therefore, we consider that by making use of the relation between the Cartesian coordinates and the spherical polar coordinates, r is equal to square root of x square plus y square plus z square is equal to square root of 1 plus 1 plus 1, that is equal to square root of 3. That is as far as r is concerned. Then theta is equal to tan inverse of module, that is equal to modulus of square root of x square plus y square divided by z, that is equal to tan inverse of, this is 1 plus 1 is 2 divided by 1, that is equal to tan inverse of root 2 is equal to, again you'll have to go for the finding the value of tan inverse of root 2, and this value is equal to 54.74 degrees. Then pi is equal to tan inverse of y upon x is equal to tan inverse of 1 upon 1 is equal to tan inverse of 1 is equal to pi by 4 is equal to 45 degrees. So therefore, the point P of xyz, that is the Cartesian coordinates, is equal to the point P11 is equal to P r theta pi is equal to P square root of 3, that is r, 54.74 degrees, that is theta, and 45 degrees, that is pi. These are the Cartesian coordinates converted to spherical polar coordinates. Now we'll find the cylindrical coordinates. Now we know that the cylindrical coordinate is equal to rho, that is the distance square root of x square plus y square is equal to square root of 1 plus 1 is equal to square root of 2. That is rho is equal to square root of 2. That is the distance between the origin and the point P in the YZ plane. Then pi is equal to, as in the last case, tan inverse of y upon x is equal to tan inverse of 1 is equal to 45 degrees. And z is equal to 1. This is z, z is equal to 1 is already known to you. So therefore, the point P of rho pi z is equal to P of root 2, 45 degrees and 1. So these are the cylindrical coordinates of the Cartesian coordinates x, y, z, 1, 1, 1. Now that is example 1. Then similarly we'll see if the spherical coordinate, the spherical polar coordinates are given, and now to find the corresponding Cartesian coordinates. For example, we'll take the second example. Find the Cartesian coordinates of the point 3, 2 pi by 3 and pi by 6. So this is r, theta and pi. R is equal to 3, theta is equal to 2 pi by 3 and pi is equal to pi upon 6. Here the spherical polar coordinates of the points are given. They represent r is equal to 3, theta is equal to 2 pi by 3 and pi is equal to pi by 6. Then we'll go for the formulae, that is x is equal to r sine theta cos pi. Then r is equal to 3. Then sine theta sine of 2 pi by 3. Cos pi cos of pi by 6. Then this is equal to 3. Sine 2 pi by 3 is equal to root 3 by 2. And cos of pi by 6 is also equal to root 3 by 2. That is the value of this 3 into root 3 is 3, 3 into 3 is 9 and 2 into 2 is 4. So x becomes 9 by 4. Then similarly y is equal to r sine theta sine pi, that is 3 times sine of 2 pi by 3 sine of pi by 6, that is 3 root 3 by 2 and 1 upon 2, that is equal to 3 root 3 divided by 4. Now z is equal to r cos theta is equal to 2 cos of 2 pi by 3 is equal to 3. This is equal to minus 1 by 2. Cos 2 pi by 3 is minus 1 by 2. Then the value of this is equal to minus 3 by 2. Hence, the point Pxyz is equal to 9 by 4, 3 root 3 upon 4 and minus 3 by 2. So this completes the Cartesian, spherical polar and the corresponding cylindrical coordinates of the point. And when x, y, z are given, how to find r theta pi. When r theta pi are given, how to find x, y, z. So in the next video, I'll be sharing you the next part, that is what we call the solid geometry part, where we are having the corresponding sphere, cone and cylinder. Thank you.